morning to everyone. My name is Sri from CSC A. Today my topic is about thrashing in operating systems. So in today's class we will see about optimizing system performance, understanding and preventing thrashing in operating systems. Introduction. Optimizing system performance, understanding and preventing thrashing in operating systems. This presentation will cover the basics of thrashing, its causes and how to prevent it. We'll also discuss the impact of thrashing on the system performance and how to optimize performance. First, what is thrashing? Thrashing is a phenomenon that occurs when a computer operating system spends more time swapping data between memory and disk than executing actual tasks. This results in a significant decrease in system performance and can cause the system to become unresponsive. As we all know that the thrashing occurs when the memory is insufficient. Suppose if a program is of large memory and in the PC and in the computer we have a little memory, then the instructions which should be executed one by one. When one instruction is executed, and to execute the next instruction, the executed instruction will be moved to the hard disk, and again the RAM will take the instruction which is used for now. So the swapping of these instructions, swapping in and out, is more than is more. Instead of executing the code, this swapping is more, and here the thrashing occurs. So let us see the graph on this. Graph contains of x and y axis, and x axis is of degree of multiprogramming and y axis is of CPU utilization. And the thrashing here is when the degree of multiprogramming is increasing, the CPU utilization is also increased. Why we increase the degree of multiprogramming? When we have a less degree of multiprogramming, then the CPU utilization is also less. When we increase the degree of multiprogramming, the CPU utilization increases. As we see in this graph, when the degree of multiprogramming is increased, the CPU utilization is also increased. But at a certain point, when the degree of multiprogram is increased at some peak, and until that range, the CPU utilization will increase. When the degree of multiprogramming is multiprogramming crosses the limit, then the CPU utilization will again decreases. As I said before, uh, when the programs in the OS is less, then the CPU utilization will be less. When it is more, means up to a limit, then the CPU utilization will be more. But if it crosses the limit, the CPU utilization will be less, as swapping occurs more than the executing of the code. So this is about the graph. And causes of thrashing. Thrashing will be caused by overcommitting of memory, poor memory management, or insufficient memory, as we discussed before. When the system runs out of physical memory, it begins swapping data to disk, which can lead to thrashing. Poor memory management and insufficient memory can also cause thrashing. As I already said to you before, causes of thrashing is due to insufficient memory or poor memory management or overcommitment of memory. So because of these three, thrashing occurs. Impact of thrashing. Thrashing can have a significant impact on system performance. It can cause the system to become unresponsive, slow down application performance, and increase disk input-output. In extreme cases, thrashing can even cause the system to crash. So when the thrashing occurs, the impact on the computer is maybe the computer gets slowed down, maybe it gets stuck, maybe the performance will be very low, and some input output devices also can cause. And if the thrashing is still more, in some extreme cases, thrashing causes system to crash. So these are the impacts of thrashing. Now, how should we prevent thrashing? There are several ways to prevent thrashing, including memory management techniques, optimizing disk input-output, and reducing memory usage. Memory management techniques such as paging segmentation can help prevent thrashing. Optimizing disk input-output can also help reduce the impact of thrashing. Reducing memory usage can also help prevent thrashing. So, for preventing thrashing, we have several ways. In those, they are included memory management techniques such as paging, segmentation, and another one is optimizing disk and reducing memory usage. When we use less memory, then the trashing will reduce. And this is about the trashing. Thank you.